So here we have the sine of the inverse tangent of 2/11. We want to give an exact answer here. So I'm just going to rewrite my problem. And to do this, I just want to recall that an inverse trig function is an angle. So this problem tells me two different things. It tells me that the tangent of that angle is equal to 2/11. And basically, since the tan inverse of 2/11 is that angle, I want to know what is the sine of theta. So another way I could ask this question is, if the tangent inverse of an angle is 2/11, what is the sine of that same angle? So to do that, we got to think about, I'm going to do right triangle here. And let's see, tangent is opposite over adjacent. So I want the opposite side to be pretty short and the tangent to be pretty long. So let's say, let's use, say it's roughly like that. So I want that to be 2. Here's my right angle, and then this is my 11 there. And to figure out what the sine is, sine on a triangle like this is equal to opposite over hypotenuse, right? Y over the radius. So I need to know what is that hypotenuse. Pythagorean theorem says if I take 2 squared and add it to 11 squared, I should get that hypotenuse squared. So that's going to give me 4 plus 121, which is 125. Oops, getting ahead of myself there. So that's question mark squared. And so question mark has to be then the square root of 125. Technically, it's plus or minus. In the triangle, we're measuring side lengths. So we're just going to go with the +1 and skip the minus. Exact answer, it's a good idea to reduce whenever possible. So I want to see if the square root of 125 reduces. To do that, I need to do some factoring. So let's see, 5 for sure goes into 125. How many times? 5 goes into 12 twice with 2 left over, goes in 25. Oh, and there's a perfect square. So the square root of 125 is 5 times the square root of 5. So that is the reduced version of the hypotenuse as an exact value. So then my sine here should be opposite over hypotenuse, or 2 over 5 square root of 5. Now we could rationalize the denominator, but I'm not a big fan of that. So I'm going to say that is my exact answer right there. How can I check it? Plug it into a calculator would be one way. Now you might say, hey, I can check it by just going right here and submitting it. Now you can, but on a test, you only get one shot. So you really want to know before you hit that button. So then on a calculator, I would just type what I was given. And let's see, does the mode matter? Not at the moment, since we aren't asked for an angle. So we had, what was it? It was the sine of the tan inverse. Yeah. So the sine of the tangent inverse of 2/11 is about 0.17. And I think that should be the same as 2 divided by 5 times the square root of 5. And that looks like the exact same value there. But if it didn't look like the exact same value, what would you do? Well, you'd go back to the drawing board, look at your notes, and ask yourself, did I make a mistake with my arithmetic up here? Is that okay? Did I reduce correctly? Did I grab the correct 2 numbers in the ratio here? So there's a few places I could have messed that up. And my usual mess ups are, saying things like 1 plus 4 is 6, or 2 times 3 is 5. These little things, sign errors, miscopying a number. So go back, double check your work, see if you can find an error. But if you don't see an error in your work, what do? Best thing to do, get a blank piece of paper, take a deep breath, try again.